Good afternoon to everyone. So, in early years, the digital circuits were designed manually using the techniques such as Boolean expression, circuit schematics, Karnaugh maps, etc. Most of the peoples used schematic based softwares like SPICE, HSpice, etc. With the increasing device densities, the choice of these traditional methods has become limited because it is a known fact that the schematics with more than 600 gates are incompressible. So it is unimaginable to think how many years would be required to design the modern chips which contains millions of transistors. It's a must for the IC designers to go for some EDA tool. So the electronic design automation tool made the multi-million IC design simple and possible. With the increasing use of computer-based design methodologies, the IC design has migrated to EDA tools. One such outcome of these EDA tools is the HDL, Hardware Descriptive Language. This HDL resembles a general programming language like C, but it is specifically oriented to describing hardware structures and behaviors. The most common use of HDL is to provide an alternative to schematics. With the increasing use of computer-based design methodologies, the IC design has migrated to EDA tools. One such outcome of these EDA tool is the HDL, Hardware Description Language. This HDL assembles a general programming language like C, but it is specifically oriented to describing hardware structures and behaviors. The most common use of a HDL is to provide an alternative to schematics. Is HDL so indispensable? Okay, let's discuss it. From an illustration, let us design a 16 into 16 multiplexer with a schematic capture and using the HDL. The multiplier is a complex arrangement of adders and registers. In this present case, we have two 16 bits input and one 32 bit product output. So, a total of 64 input outputs approximately. The circuit requires 6000 equivalent gates. So, in the schematic implementation, all the required gates have to be loaded, positioned on the page, interconnected, and the input output buffers should be added. This will take at least 3 days of hard time. But the HDL implementation, which also needs 6000 gates, requires 8 lines of text and can be done happily in 3 minutes. This file will have all the informations required to define a 16 into 16 multiplexer. So simple example for this code. So entity mult is port A and B. This is input STD logic. So here you are having 15. So down 15 down to 0. Then Y is your output port. So we have mentioned it as out STD logic. That is 31 down to 0. Then end mult architecture behavior. So begin. Hat to Y less than or equal to A into B and end behavior. So the HDL implementation has all the 6000 gates, only one text file, 3 minutes to write, completely the vendor independence. This clears the importance of using a HDL in the digital order design. So the types of HDL we can see. There are two standard HDLs that are supported by IEEE. One is VHDL and the other is Verilog HDL, which originated in 1983 at the Gateway Design Automation. Both Verilog and VHDL simulators gained the acceptance of the designers to simulate large digital circuits quickly. Then what is VHDL? It is very hard, difficult language? No, it is an acronym of V, very high speed integrated circuit, and H for hardware, D for description, and L is a language. So very high speed integrated circuit hardware description language is called as the VHDL, a language developed to describe the complex digital circuits. It is like a C-like language that supports wide range of description styles, that is structural description, data flow description, behavioral description, and mixer descriptions. So how it has been developed. During 1980s, the rapid advances in integrated circuit technologies provoked the idea of developing a standard design procedure for digital circuits. In VHSIC programs launched in 1980s was an initiative of the Defense Department of US to push the state of the art in VLSI technology, and VHDL was proposed as a versatile hardware descriptive language. So Woods Hole's workshops held in June 1981 in Massachusetts. In July 1983, a team of Informatics, IBM and Texas has developed this VHDL. In August 1985, the final version of the language under the government contract was released, that is VHDL version 7.2. In December 1987, it becomes IEEE standard of 1076 to 1987 and in 1988 and ANSI standard. In September 1993, VHDL were standardized to clarify and enhance the language. VHDL has been accepted as a draft international standard by the IEC International Engineering Consortium, VHDL 1993, 1997, 2000, 2002. So this is the design flow for the VHDL. So VHDL entry, RTL level, then compilation, netlist gate level, then optimized netlist gate level simulation, and place and route. This is physical devices. So VHDL terms. Synthesis. Synthesis means we have going to converting a code to a circuit. Simulation, giving an input and verifying the functionality of the circuit. Test bench helps in generating an input signals for simulation. Specialities. The VHDL allows the designer to work at various level of abstractions, behavioral, RTL, Boolean equations and gates. The VHDL allows various design methodologies, top-down, bottom-up, delay of detail. Very flexible in its approach to describing hardware, provides technology independence. VHDL is independent of any technology or process, ASIC, FPGA, etc. Then VHDL portability. VHDL code get designed complex any synthesis tool, any vendor devices, that is PLD, CPLD and FPGA. It can be utilized. Then format. It is a free format language. No formatting conversions such as spacing or indentation imposed by VHDL compliers. So space and carriage return treated as the same way. Example, if A is equal to B, then R if A is equal to B, then R if A is equal to B, whatever, if you are giving a space, all are equivalent. There is no special format for this. Because VHDL is a standard, VHDL design description or the device independent, allowing the designer to easily benchmark the design performance in the multiple device architecture. The same code used for designing with the programmable logic can be used by ASIC vendor to produce an ASI when the production volumes warrant a conversion. So VHDL is a well-suited language for designing with programmable logic, and it is gaining its popularity. Designing with the large capacities, that is CPLDs, that is complex programmable logic devices, and FPGAs, field programmable gate arrays of 600 gates to 20K gates. The VHDL delivers portability of code between synthesis and simulation tools, device independent designs and easy ASIC migrations. VHDL is an open standard language, not a proprietary language. Thank you.